Hello, ladies and gentlemen. This is the presentation of CHNG 5003 Green Engineering. In this presentation, considering reasonable assumptions about future carbon dioxide regulation, renewable energy targets, and economic policies, we would like to make a recommendation on CCS and regulations. The latest government data on greenhouse gas emissions showed unseasonal rise in emissions that continues a trend of rising national emissions which began in 2014. The projections showed recent jump was almost entirely driven by an increase in emissions from the electricity sector, which the emissions from other sectors remain stable or dropping. The latest projections show that Australia has emitted just over 23% of its carbon budget, the amount of carbon it can emit while doing its fair share to keep warming under 2 degrees, according to Climate Change Authority. Based on the rate of emissions over the past 12 months, that budget will be blown by 2031. That is why CCS is vital for reducing emissions across the energy system. Already it features some good news. After record growth for the second year in a row, both solar power and onshore wind are on track to meet the 2025. The number of electric vehicles passed 1 million milestone in 2050, and outlook for nuclear power improved, with the long-term scenario targets more achievable than previous thought. However, most of the clean energy technologies examined are not on track. Therefore, policymakers must consider CCS. Today, we have 3 main types of carbon capture technologies. The first one is post-combustion, the second one is pre-combustion, and the last one is oxy-combustion. The most prevalent capture technology has been post-combustion carbon dioxide capture, which can be added to existing plants to filter carbon dioxide from their fuel gas. Installing post-combustion technologies to existing power plants is a core advantage, given the average power plant life cycle of the 40 years or longer. The 2 main challenges for the post-combustion capture technologies include the large volumes of gas that must be handled, thus requiring large-scale equipment and resulting in high capital costs, and the amount of additional energy needed to operate the press. Post-combustion technologies enable around 90% of the carbon dioxide to be captured. As a result of its refloating options and applicability to both the power generation plants and the majority of industry plants, post-combustion carbon dioxide storage technologies are the most widely used. The second one is the pre-combustion. In pre-combustion, the carbon dioxide is removed from the fuel prior to combustion. The fuel conversion procedure required for pre-combustion is the most complex that involved in the post-combustion. thus making the technology more difficult to apply to existing plants and best fluid simulations with a facility. The pre-combustion capture increases the carbon dioxide concentration of the fluid stream, requiring more equipment and different solvents with lower regeneration energy requirements. And the last one is oxy-combustion. A traditional fossil fuel power plant is operated by a combustion fuel and air. The distinguishing characteristic of oxy-fuel combustion with carbon dioxide capture is that combustion is carried out with oxygen instead of air. The advantages of oxygen-fuel combustion is that because the flue gas contains a high concentration of carbon dioxide, the carbon dioxide separation stage is simplified. This technology therefore makes it possible to capture 100% of carbon dioxide. The high cost of producing pure oxygen, however, acts somewhat as a barrier to the wider adoption of oxy-fuel carbon dioxide capture technologies. According to the data from EIA and research of University of California, compare the cost of discussed three methods of CCS are shown in these three figures. The blue bars are pre-combustion, green bars are oxy-combustion, and red bars are post-combustion. The overall performance of these three methods show that the oxy-combustion has the best financial effectiveness and the lowest cost. The oxy-combustion is around $1,400 of the capital cost, 80 levelized cost, and $26 per ton of carbon dioxide avoidance. What's more, by comparison about the efficiency, the post-combustion and the oxy-combustion both performs best. Generally speaking, consider two items. The oxy-combustion has the best performance of the cost and efficiency. But what can become an alternative ways of CCS? We will propose technologies that remove carbon dioxide from the atmosphere, so-called negative emission technologies. Carbon dioxide may be directly removed from the atmosphere or indirectly, stored as fluid in geology formations or in some other stable form. So that's what is our plan B. The first method is direct air capture, artificial trees. The purpose of this idea is to create fortress with the carbon capture trees to remove carbon dioxide from atmosphere. It stands passively in the wind like a tree. It will remove carbon dioxide from the air faster at higher levels than the natural trees. Can be used anywhere, for example like airports, highways, etc. And the second method is BECCS, which is called bioenergy with carbon capture and storage. It's a technology that integrates biomass systems with geology carbon storage. With this process, part of the carbon dioxide released by the biological process can be stored into ground to release the negative carbon dioxide emission. What's more, it's biochar. It can generate fuels by forming biochar. Furthermore, when the biochar is retained into soil, it can increase the carbon content of soil permanently. This method can both reduce greenhouse gas emission and improve the soil quality at the same time. The third one is ocean liming. It's a method to strengthen the ability of the ocean to absorb carbon dioxide and reduce the acidity of the ocean at the same time. First, the limestone is transformed into lime, and the carbon dioxide generated from the process can be captured and stored. Secondly, the lime can react with the carbon dioxide dissolved in the ocean to generate bicarbonate ions. Therefore, the acidity of the ocean can be reduced, and the ocean can absorb more carbon dioxide from the atmosphere, which can slow down the global warming phenomenon. Data analysis reveals that the most prospective way of CCS is oxy-combustion, that is the economical most efficient, as well as giving good results of effectiveness. But to reduce carbon dioxide emissions, it is recommended to combine existing CCS technologies with alternative negative emission technologies, as well as green power generation. That's all. Thank you.